So for example, let's consider the region that is bounded by y equals e to the x, y equals e cubed, and write that very nicely. It's supposed to be e to the third power. And the y-axis, we want to find the volume if you rotate this region about. Part A, x equals 0. Part B, y equals e to the third power. So first let's sketch out this graph. So it's e to the x. E cubed is a constant function. And then the y-axis. And so the region that is bounded by those curves is this region right here in the first quadrant. And for the first problem, we want to rotate this region about the line x equals 0, which is the y-axis. So the list of questions to ask yourself as you do this. The first question is, do I use the disk method or the other methods? We use the disk method here because there is no gap between our region and the axis of revolution. Right? There's no gap at all between those, so we need the disk method. And the second question is, which variable do you have to be in terms of? Are you in terms of x or are you in terms of y? We are in terms of y because we have a vertical axis of revolution. And the way to see that is that we line up our rectangles along the axis of revolution. So the rectangles will look like this. I'll draw them in black so you can see them better. And as you can see, the height of these cylinders, which is the base of the rectangles, is the change in y, which means we're going to have dy, which means everything's in terms of y. So when in doubt about your variable, remember that you line up your rectangles along your axis, and then figure out if you have delta x or delta y. So our volume for part A is going to be the integral from c to d, pi r of y squared dy. So let's do the easy stuff first. What is c and d? Well, we're in terms of y here, so everything's going to be in terms of y. This is where we start. This is where we finish. The bounds are always where the region starts, where the region finishes. The region starts at this point, which is 1. The region finishes at this point, which is e cubed. So the volume is going to be the integral from 1 to e cubed times pi r of y. R of y tells you this distance right here. What is the radius of each of these rectangles? Right, so this distance, that is r of y. And when you're in terms of y, just like with the area problems, this length is just the right side minus the left side. So the right side is this curve. This curve right now is a function of x, so we change that to be a function of y. So the right side is log y. The left side, in terms of y, this is x equals 0, so it's y equals, or sorry, so it's 0. So it's log y minus 0. And so it's just log y. And there you have it. And now we can't do this integral by hand. We could do it in a calculator or a computer, and it will give us some number. But the important part is that we used the disk method because there is no gap. We were in terms of y because we had a vertical axis of revolution, which will give us delta y. The bounds we find by where the region starts and where the region finishes. And the radius of each of those cylinders that we use to approximate it is this length right here. What is the length from the y-axis to the curve? In terms of y, that is log y minus 0. And there you have it. Now part B, about y equals e to the third power. I'm just going to redraw the region. There we go, that's good enough. Actually, I'll make it a little bit nicer. This is y equals e cubed. This is y equals e to the x. And we're going to rotate it about e cubed. So we go through our list of questions. We need the disk method here because there's no gap between our axis of revolution and the region, and we are in terms of x because our axis of revolution is horizontal. Because again, if we were to make those rectangles, they'd be lined up going this way, and the base is delta x, change in x. So the volume will be the integral from a to b of pi r of x squared dx. What are the bounds? Well, the region starts right there, which is 0, and it finishes right here. This is where e cubed and e to the x intersect. That means x equals 3. So our region goes from 0 to 3, because the bounds are always the start to the finish of the region, times pi. Now r of x, what's r of x? Well, just like area, when you're in terms of x, any length is the top minus the bottom. Right, because r of x is the radius of each of these cylinders, which is this length right here, which changes over x. Now top minus bottom is e cubed minus e to the x. And if you flip that, it would actually give the exact same answer, but it would be wrong because you would have a radius which is negative. Because if you did the bottom minus the top, you would go small minus big, which puts you in the negatives, and a radius is a positive quantity, it can't be negative. It gives the same answer because you square it, but it would still be wrong. So the volume is pi r of x squared dx. So that is the disk method. There is not a gap between your boundary and your axis of revolution. If you're in terms of x, the radius is top minus bottom. If you're in terms of y, it's the right side minus the left side. And you find your answer. We'll do some more examples in a bit. But first, let's move on to the next method of finding volume.